Alright, here we're going to look at solving uh, basically when the exponent is in the power, solve by equating exponents. Now what does that mean? That means we got to have the same base. So we'll write the original equation here. Rewrite each power with the base. Now here 4 goes into both of these. Both of these can be written as powers of 4. So 4 to the third power represents 64, and 4 squared represents 16. Now, what we have to be careful of here is we'll end up multiplying the 3 times x. We end up with 4 times 3x. And let's go ahead, well, it's 4 to the 3x power. Let's go ahead and distribute this 2 through up here. So we end up with 2x plus 2. Okay, now, power of the property. So anyway, now we're going to write this as 3x, okay, is equal to 2x plus 2. Okay, so we'll end up solving this, and I'll just do this over here and then fill it in over there. So 3x is equal to 2x plus 2, subtract 2x, and we end up with x is equal to 2. Okay, so the solution is 2. Now we can check by replacing the 2 back in for the variable. Okay, so let's go back to the original equation and put in 2 for our power, so 64 squared gives us 4,096. Okay, and then we put in 2 here, so we end up with 16 to the third power, which is 4,096. So it checks out. Okay, so let's look at another example down here. What I would do, we have the base of 3 here, so is there a way I can write 9 as a base of 3? Yes. 3 squared gives me 9, so we'll write this as 3 to 7x minus 3 is equal to 3 squared times 2x. Now the 2x came from the problem and 2 comes from this, so like 3 squared gives us the 9. So now I would just write this as 7x minus 3 is equal to, now you may want to go ahead and write this as 4x. Just went ahead and multiplied the 2 times the 2 to get to 4x. Now I'm going to get like terms together. Now the temptation sometimes is to move the 4x over here, which is possible, but then we'd have to move the 3 back over there. So the first thing I'm going to do is just move the 7x. It's kind of save me a step. Okay. Now when I do that, though, I have to be careful to bring down this sign with this. So I get negative 3 is equal to 4x minus 7x. I get negative 3x. Okay, divide both sides by negative 1, and I end up with x is equal to, sorry, I'm dividing 3 by 3. Negative 3 by negative 3, so I end up with 1. So x is equal to 1. Alright, now we're going to solve by graphing. Now the way we do this is we're going to graph the 2x and then graph the 1/4 to the x minus 3. Okay, and then if they intersect, then that will be our answer. Now what I'm going to do here is I'm actually going to use a graphing calculator. And this is online, and so I type this in. If you type in online graphing calculator, this will pop up. So anyway, so I graphed it. Now you'll notice in red, the red is the 2x, 2 to the x power. Okay, then the green is the 1/4 to the x minus 3 power. Okay, and so when they intersect is an answer. Now, this one may be obvious that where it intersects. Now, but if it's not, I'm going to go over here to intersection, and I'm going to click both of them, and then I'm going to say find intersecting point. So it intersects at 2, 4. So that means the x value is our answer for this one. So for this, our answers to this is going to be 2. Alright, so on our graph we found x equal 2. This is when they intersected, so 2 is the only solution. Now if they intersected twice, there could be 2 possible solutions, but for these there's only going to be 1. Alright, so let's look at another example. Alright, now we have 4 to the x power and 1/2 to the x minus 1 power. Okay, so what we're going to do again is we're going to graph y is equal to 4x, and then we're going to graph 1/2 to the x minus 1, and where they intersect, that would be our answer. Okay, here again I'm on an online graphing calculator. If you have a calculator, you can punch them in, or if not, you can use the computer. Alright, so again, I'm going to graph, I'm going to go ahead and type it in 4, okay, to the x power, okay, and then I'm going to type in 1/4. Now I'm putting it in parentheses so it knows to take 1/4 and not just 4 to the power. So 1/4 to the x minus 1 power. Okay, now again I put it in parentheses because if I don't, it'll only take it to the x power and then subtract. Anyway, so I'm going to graph these. Okay, and then they intersect. Now you notice they'll intersect somewhere in here, so it's less than 1. So it'd be kind of hard to tell from this graph. Now I could zoom in and maybe they're not going to give me any better numbers to work with. So then that's why I went to intersection, and I'm just going to click there. Okay, and then it intersects at 0.5 according to this. So my x value would be my answer. Oh, but I did the wrong problem, so it'd be good if I typed in the right one. Oh, this was the one from before, so let's go back to the equations. That's the one we did earlier. 4 is right. This should be 1/2. Okay, and so our answer will be different. The process is the same. We type in the answer is hit graph. Okay, they cross there. It still doesn't cross at a nice point of intersection like a whole number. So let's go to intersect. Click, click. Hit graph and find intersection. Okay, I didn't select. Alright, 0.333, which is I would take that as an answer, but as a decimal form it's going as a decimal form it would be 0.333, or as a fraction it'd be 1/3. Okay, but again the important part is the answer to this problem, okay, is where they intersect. Right there. So we intersect at 1/3 and something, 1.587. So that's that point right there is represented here. But our answer is the x value, which again I'm gonna write this as a fraction. That's the same as 1/3. So our answer to this is x is equal to 1/3. Now if I wanted to check my answer, again we could check by placing in 1/3 for x, and we should end up with the same thing on both sides. Alright, here we're going to do with inequalities. Just means there's more than one possible answer usually. Means that there's a range of answers. Similar process. We have 3 as our base here, 9 as our base here. So 3 will stay the same. But we can write this as 3 to the squared. Okay, and so what we end up with here is 3 to the 4z power is less than or equal to 3. I'm going to go ahead and distribute this to the 2z plus 6 power. So we're going to end up getting rid of our bases so that we have 4z is less than or equal to 2z plus 6. Now here, what we would do is just go ahead and solve and treat this like an equal sign. The only difference is if we cross it with a negative, we have to change the inequality around. So I'm going to solve it over here. So let's go 4z. Alright, subtract 2z. We're not multiplying or dividing, so we don't have to worry about the inequality. So we end up with 2z is less than or equal to 16. Okay. Sorry, 6, not 16. Divide both sides by 2. Z is less than or equal to 3. Alright, we're going to check to see if it's reasonable. We can plug in 2 in. We're going to check points above and below. So we'll check one below 2. If I take 2 and I plug it in here and I do this, I end up with, if I go through all the process, I end up with 6,561 is less than or equal to 5,949. So that makes sense. Okay, we'll do the same thing right here. Okay, and so if we plug in 4, we get a statement that's not true. Okay, so because z equal 2 is a solution of the inequality and z equal 4 is not, then the solution is reasonable. So it is reasonable. So that concludes part 1 of this. I'll go ahead and do part 2 in a second and go back through it for you.